Okay, so the recording is on. So when you ran that system here, it removed the symbolic link in there and then created a symlink ctc system did default target to this link here. Now this is where the symlink gets into the usage here. So you see here default etc system d system default target. Okay, so this file got removed, but then a new target, this file got updated to this file here. Okay, so if we go into the previous file here, it didn't change anything here because we manually tried to change it here. But let me quit this. Let's go into the folder first.
Can you show that command one more time, Mr. Zafar?
I'm sorry. Okay.
Can you show that command?
Systemctl.
Yeah. Oh, okay.
Okay, here. So here what we're looking for is within this here, what I want is let me clear this here. Systemctl crypt targets. Okay, so this is one of the file here, okay? And give me one moment here. I'm doing graphical target, multi-user target. And if I do multi-user, I shouldn't have edited this one here. No, this part is not valid. Okay, so let me remove this. System, where is that command I ran? Okay, it's showing here, right? Set default. Okay, so system ctl get default. Okay, so right now this is the file, and if I edit, it says graphical here, right? Bear with me, guys. I did a mistake here. Okay, so this would be multi-user system. Uh-oh. Okay, so whatever I did so far, don't worry about that. Only worry about what is happening here. So we usually worry about two files here that are getting So this command is used for changing default run level. Okay, and how is the default run level changed? Okay, so this file systemcdl defaulted target whenever you use the command, you use this command, this file, not that file, this file located in etc defaulted target, the symbolic link changes. Whenever you use this command, the symbolic link for the file is changed to appropriate run level file, changed to associated. Is changed to associated run level file located in this folder, in the following folder. Okay, so this folder holds the associated files with it. So I'll show you how. So let me go in here, change run level. So most of the time we are dealing with only 2 run levels, okay? So we are dealing with the multi-user target and graphical target. Okay, so most of the time you are only setting default between multi-user or graphical. So what is multi-user is run level 3, run level 3 or run level 5. Okay, so let's go take a look at the run levels here. So run level 0 cannot be a default run level, right? I mean, if you start the system is going to shut down. Okay, and the rescue mode, you don't want to start the system and you want it to automatically go into rescue mode, because when the system is starting up, you could interrupt here. When you interrupt here, the system then you will give an option here to go into rescue mode. So you can't set it as a default run level. Okay, number 2 is useless to set as a default run level, because 1 and 2 are usually for troubleshooting modes. Okay, and then number 3, you could set it as default mode. Number 4 is not used. Number 5 is graphical mode. So now you only have choice between either setting the number 5 as a default. Whenever you start, goes into the default mode, or number 3. By default, number 3 is there. If you want to change it to go into GUI mode, you do that. And then reboot, you cannot change, you cannot keep the reboot as a default mode here, right? So we are only worried about 2 of them. So now, if you look here, when we ran this command, what happened was, this is the file here. This file is the one the system is going to read. When it's booting, it's going to read this file here. But since this file is a symbolic link, so the symbolic link was now is changed to graphical mode. So if the system is going to read the default mode, it's going to actually read this word. Remember when we went into the when I was showing you symlinks and hard link and soft link, this is where it's coming from. Okay, so instead of say it's writing 2 different files in 2 different locations, it's saving. It's just altering the default target file is going to go into the different graphical tag. All right, guys, who has questions here? I'm not going to move forward here. Okay, so I'm going to just wait here. So I'm going to say.
So run level 3 and 5. These files work for those.
Yeah. So okay, I'll show you here. Okay, so give me 1 second. So we have this many files here, right? So okay, so we are worried about this file here. So if you do pwd ls-l, so actually what I'll do is, so that you know, you see the full path here.
So we use this file to upgrade the system?
No, it's just the location of the file here. This is the main file here. You user lib systemctl your main.target, and then I'm gonna get no, not this folder. Okay, so let me just copy this information here. Okay, so So let's go into, I'm going to close one of this window. I don't need this. Okay, so I'm going to go into CD. I'm going to do ls-l and etc system D system default.target. Okay, this is the file. This is the file which the system is using to find out which target it's using. Okay, now if you look at this file here, this file is right now actually the symbolic link for the file which is sitting in here. So the system, when it reads default.target, actually it's not using this file located here. It's going to use the file which is located here, because this is just a symbolic link. All right, it's going to confuse you. I will make sure the confusion is over before the class is over. Okay. During boot, system will read the default.target will read the following file.
So this is a default file.
Yeah. So which one is the default file here? It's this file here. Okay. So we'll read this following file. This file is actually a symbolic link, soft link for whatever the default default run level is set to.
Okay, so Mr. Zafar.
So now if you do systemctl get default, okay, yeah, go ahead, sorry.
A target and the run level default, what are those two?
Yeah, I'm coming.
Okay.
So let me clear the screen. When you type systemctl get default, it's saying multi-user.target is the default one right now. So the file is actually a soft link to the whatever file. So right now it's a multi-user.target. So why is it saying multi-user.target? So you have to do ls-l for this file here. If you do ls-l for this file, let me make this bigger here. Oops, not that. Okay, so
थोड़ा
you
font बढ़ाइए था.
okay, yeah, sorry.
It says all the permissions.
Yeah, you got read write permissions. If you are ready to quit the job and you want to make mess, you mess around some of these things there, okay? I'm telling you, I mean, once you grew in the job, you wouldn't be, people usually can't detect what is happening after the fact. Like FBI, CIA, they have all the technology in the world here because they can't still track it in a real time. You know what I mean? If something is happening, usually it happens after the fact. Okay. So now what is happening here is if I do ls hyphen this is how it is normally set, okay? So what I'm going to do is let's go ahead and restart the system. Yeah, I'm going to get rid of this. We don't need this anymore. At the moment, let me go ahead and restart the system, okay? So whenever you're going to restart, the system is going to read this file here. In turn, that file is being read by this file. Okay, this file is getting, at this moment, right now, is getting this information from this file here, which is multi-user.target. Init 6, I'm going to do restart the system. Multi-user.target is nothing but run level 3.
Is a graphical target the file?
Yeah, now multi-user is, so we are dealing with only two files here. One is going to be a graphical and other one is the multi-user target here.
Okay.
Default one. So now the default is multi-user, okay? So it's going to go if it's a multi-user, it's going to go into black window, okay? So I'm going to restart the system. Okay, now what is going to happen now is if I do systemctl get default, it's going to be multi-user. Now what I'm going to do is I'm going to run the command systemctl okay, so before that, let me run this command here. Let me run ls-l for this, okay? So look in here, it says multi-user still. Now what I'm going to run systemctl set, instead of get, set default, and the command would be graphical, right? So the command would be graphical.target. Okay, so keep an eye on this file here. This file is going to change and hit enter. And it's giving you even that the default has been changed to the graphical. So if I run the ls-l and default.graphical, now take a look here. The file has been changed. It's changed to, instead of multi-user here, it's changed to graphical target. Okay? Now you do systemctl get default. It says graphical here. So when the system is gonna reboot, it's gonna go into a graphical mode. Okay, I push escape key, like it's doing a lot of things here. There you go. I didn't physically do anything. So if you restart this system 100 times, it's gonna go into default mode, which is default right now is graphical.
So the user lib systemd system graphical target file holds the etc systemd system graphic target file, and that allows us to control what pops up on the kernel.
Yeah, very good.
Okay.
Very good.
But in order to do that, we have to go into the file and change it,
No, you just run this command.
or just run the command. Okay.
Yeah, I was thinking of old days.
Oh,
You
okay.
change the, you run this command, and that command is changing it for you.
Okay. So what you were doing before when you went into the VI didn't have to do with.
Yeah, I didn't have to do it. I was thinking of Red Hat 6.
Oh, okay.
Yeah, I forgot. Because I worked on Red Hat 6 a lot, extensively, compared to Red Hat 7. So here, what I'm gonna do is,
How often we get a chance to work on practical graphical user in the practical life, sir?
you shouldn't be. If you are a true Linux admin engineer, you will hate it. I hate it too. Nobody works in graphical, man. Come on. Maybe some.
Why don't you like the graphical?
Huh?
Why
Okay.
why don't you like the graphical?
I'll give you an assignment. Okay. Create a. Try to create a LVM, not LVM. I'll give you an easy task, and then tell me by next week if you could do it in graphical mode easier.
Okay.
Try to create add a new disk and try to create like a LVM or something. Go into the Google it and see if you are able to do it LVM the way you want
Okay.
it, and then if you could do it. Okay, so the above explanation I'm gonna do is, let me create 3 boxes here. Okay, so when I'm gonna do systemctl, no, systemctl, systemctl get default. Okay, and then it says if you do ls-l, no, not this one, systemctl get default. I'm gonna get for where is the one that says Okay, hold on. Actually, I'll do it the way I'm normally doing it. Okay, so command to get present default run level. Okay, so you type systemctl. You type systemctl. So you type systemctl, and then this information comes out, right? So now it's saying that where is my thing here? Okay, so now if you do, so this is the output here, right? Okay, so if you look at the file, if you look at this file, so ls-l systemd, if you look at this file, so default.target is, this file is actually reading this file here. Okay, if you look at this file, default.target file, default.target is actually a soft link. Actually soft link for file multi-user.target. Okay, now we change this here. Now change the default file, default run level to graphical, run level, default run level to graphical, which is run level 5. Okay, so this command will change that. So this is the command. which changes it. Okay, so okay, so during boot, system will read the following file. It is reading this file here. Okay, so let me put it in highlight. This file is actually a soft link for whatever the default run level is. Okay, so to get the default run level, we did this, right? Systemctl get default. If you look at the default.target file is actually a soft link for the multi-user. Okay, everybody get it right? When you have an arrow like this, that means it's a soft link. Okay, don't disappoint me, guys. Let's go up here when I talk about soft link. Okay, here we talked about this here, right? We created a soft link, and soft link is represented by a little hyphen then an arrow. So here, if you do like ls7ls file is actually a soft link for that file in that location. Okay. Okay, good.
Soft link is basically like a shortcut.
It is a shortcut. It's dumbest file on the planet. It's just the dumbest files on the planet. That's it. It's not. I mean, it's meaningless, but it makes a lot of meaning over here. If you name the soft link something else, you're gonna crash the system. You're gonna definitely crash the system. There is no question about it. Now change the default run level to graphical. Okay, so whenever you ran this command here, what happened? The system changed the soft link. So it's explicitly saying before you see default.target was associated with this multi-user.target. Now when you ran this command here, so default.target is now associated with the graphical.target. That will change the run level.
Instead of the multi-user target.
Yeah, but the name here, default.target, is staying the same. That's what it is. That's what it is. In old days, you have to go in there and manually edit the file, but the new one, all you have to do is run the command, and you don't have to worry about what is happening in the background. Okay, now that will lead us to the system boot process here. System boot process is very important. It's a interview question, what I'm going to show you next. And everybody went to the website here and looked at this, right? The questions here, I'm start memorizing them. At one point, I memorized all of those. So these are the little bit classic questions here. It probably covers 6 also. But memorize it, blindly memorize it, what you have in here, okay? So What you might want to do is make a flashcards out of this. How many questions I have here? 60, I think. Uh,
65.
yeah, 65. Memorize all this here. Okay, we're gonna use a find command du. We use that. LSOF is coming up. F user is coming up.
So, Mr. Zafar, would you advise us to look at the interview questions and then go back into PuTTY and like test what we know?
Yeah, definitely. You definitely do that. Do that, yeah.
Yeah.
Oh, a lot of things are coming up. But here, for LVM, make sure you're doing it, but also memorize this. Chmod, RPM, we looked at RPM. And okay, yeah, I'm not gonna spend too much time on here, okay? So everybody is clear about this, right?
Mm-hmm.
Actually, over here, I'll put in the file location. Main file read by system is this file. Okay, and and Okay, that should make sense now. If you're setting it to level 5, it's going to do this. And then, so run level 5 is vulnerabilities multi-user.default. And this one is graphical.target. Okay, does it make sense? Main file read by system is etc default, and if you do systemctl command, this command is changed to use the default run level. So either you use the systemctl and multi-user.target or graphical.target. Okay, so here you use the command systemctl graphical.target, and it changed the run level here. Okay, now what we're gonna do is I'm gonna get default systemctl get default. Okay, graphical, right? So we know the system is going into graphical mode. Okay, there is no question about it. Now if I do systemctl set default, before that let me show you one more time. ls-l etc, what is the location? systemd system default. Okay, so look at this here. The soft link is this here. Now if I do systemctl get set default, okay, multi-user, multi-user.target. So it says it removed the original link and then recreated that link to the multi-user target. You see a difference between here and here. So if you do the ls-l, now you see a multi-user target here. Same exact file, it's showing a multi-user target. Earlier it says graphical target here. If I do init 6, the system should boot into, now when the system boots, it will boot into our favorite run level, which is run level 3.
So Zafar,
Yeah.
whichever run level the system is on, if you use that command, it'll change it to the other one?
Yeah.
Okay.
Right now it was on target, right? Graphical target.
Yep.
And we change it to multi-user target, which is 3. So then you could do it. But if you want to do it temporarily, you just type it there without restart. What will happen if I type init 5?
I got it.
Huh?
It'll come to graphical.
Very good. It will come to graphical, but it's not going to be default. When the system reboots, it goes back into the default mode. So if I do init 5 here, look, it's going to change into graphical right here, right in front of your eyes. See, it went into graphical mode, but that's only temporary unless the system reboots. So even if I get it like systemctl get default, there you go, still says multi-user target. Why is it saying multi-user? Because this file has not changed yet. So let me restart it again. It's going to go into the regular mode here, run level 3, because this file is set to multi-user mode. Uh-oh. What did I do? Failed to get the default target, cannot send after transport endpoint. It went into run level. Why it went to run level? Till startup result is done, has finished. Initial RAM disk unit system startup is now complete. 22 GUI received, started debug system message box. Unit debug system has finished starting off. Why did it fail though? I don't see it. Let me just restart it one more time. You could push the escape key to see actually the files which are running. So what I'm going to do is it failed to get in there. I'm going to manually change the link.
It's the spelling. It's not system. It's SYSLEM.
Where?
If you see on the right side,
Here?
on the is a putty. It's up there.
Where?
It's a whatever symbolic link from SYSLEMD SYSTM, not is not created symbolic link from etc. The spelling, yeah, this line.
Yeah, symlink.
Yeah, but if you go, say the from PLC,
It's symlink. I think I told you it's called symlink, symbolic link, soft link. They're all the same.
right? But
Yeah.
the spelling on that is of the file,
This file?
but no under this, yeah,
This file?
yeah.
Lib user lib systemd system file multi user dot target. Yeah, this is correct.
Uh,
Did we use a file that we were already using? Like, were we already using the multi-user file, and then we try to do it again?
It doesn't matter.
No.
What I'm gonna do is I may have to run the isolate command here. System D unit equals var log boot logs. Okay, let's go into boot log. So var log I think it has to do with the memory here. So I'm able to create a file here. Uh, cannot send after transport endpoint shutdown. System CTL. set default. Okay, it might work now. It's working. And let me see if I could connect. I can't connect. The IP address might have changed. What is the IP address is 192.168.56.150, right? It has changed, guys. I don't know why. Or 106. 106. One 158.168.56.150. It's working. Let's see, 106 is working. Yeah, they all are working. I may have corrupted the file, I think. If I go to what is the location? CD. Not this file here. So ls/usr lib systemd system graph multi-user. Oh, look at that. Because I messed up that file. So I'm gonna just shut this down here. The multi-user file, I think I messed it up. So that's why it's not coming up here. So we're not gonna waste too much time on that.
The file was empty?
Yeah, that file is empty. I may have overwritten it. So this is why you got to be careful how things are working. So now, what would you do is, if the file is empty, what you do is you go in there and a different system and copy the file from there. Okay. In fact, I should show you how I would do that. But there is no network.
Can you say that one more time, Mr. Zafar?
Huh?
Can you say that one more time?
So remember how that file was empty, right?
Yeah.
So how are you going to fix that? You go into another file, another system here, and copy that file using SCP. I think I didn't show you guys SCP yet. I think it's still coming up.
Yeah, not yet.
Yeah, I showed you copy, right? SCP is you copy over between two systems. So I will show that later. That's coming up.
All right, cool.
So I'll make a note here. In fact, we'll come back to this problem here when we do SCP, and I will fix the issue. We'll come back to this sucker here. So I want to really cover how to crack the system, how to break into the system today, and then yeah, I'm gonna go over 10 minutes over. Is that okay, guys?
Yeah.
Okay, so let's see. Before that, I'm gonna go into how to crack the system. Now I will
We follow you on this, or should we just watch?
You could watch,
Okay.
and then the instructions are not going to change how to crack the system here.
All right, cool.
Okay, you know what? Actually, before that, I need to show you how the run level, the system boot process. Okay. system boot you could say system boot process, or all this system initialization, or system or boot process. All this means the same thing here, okay? So what is happening here is when you push the power button, okay, so system goes through the following process. Before it is ready to be used. Okay, this is true for any system, either if it's Windows or not, up until it started hitting the so when you first power on, what will happen is when you push the button, what will happen is when you push the button, your BIOS, everybody heard about BIOS, right?
Yeah.
But before even it reads the BIOS, there is a chip built on the motherboard. It's a little chip built on the motherboard that holds like a little software called firmware. Okay, when your power button is turned on, it goes in there. And this is how the old BIOS looks like, the Windows.
Yeah, yes.
Yeah, I mean, I think you all should know this here. If this doesn't work, the system is not going to go anywhere. It's going to check the hardware of the BIOS, okay? So what happens is the BIOS, first step is what is the very first step? The computer is powered on. Okay, and then what happened is
Just read the BIOS.
yeah, it reads the BIOS. Very good. It reads the BIOS, which is sitting on physical chip. Physical chip on motherboard. Okay, so what does BIOS does? BIOS performs
Different test.
yeah, it does POST. POST. That means power on self-test. Okay, so give me 1 second here. It does power on self-test, right? Yeah. Okay. Then what happens is it takes the Give me 1 second here. So BIOS performs self-test, then it
Turn on different switches or devices.
yeah, actually this is what is happening. Power BIOS in installation, BIOS passes control to first stage of bootloader. Okay, so then BIOS passes control to first stage of bootloader. Okay, and then what does bootloader do? BIOS passes control to first stage of bootloader, which resides in MBR. Okay. Bootloader sits in MBR. MBR is what? MBR is master boot record. That's what it says. Master boot records is on the hard drive. Power on self-test. So what happened is it goes really fast. In old days, you used to hear like a PC used to make a noise, right? Pop, boom, little beeps. That's what is used to do all that here. So I'm not gonna too much spend time on it. First stage. So first stage of bootloader passes control to second stage. Okay. So MBR, a bootloader sits in the MBR. Okay, master boot record, and it has 2 stages, I think, right? First stage of bootloader and second stage of bootloader. Okay. So bootloader has 2 stages. Okay. First stage of bootloader passes control to the stage of bootloader which resides in boot partition. So if you go into boot partition, see we have this little file called grub2. Okay, that's where it's gonna go in there. So before that, I'm gonna explain that here. First stage of bootloader passes control to second stage of bootloader. First stage is not doing much, it's just passing the control. So it got the control from BIOS. After post performs the post. After BIOS, it passes the control of first stage of bootloader. Okay. Yeah. See. So what I do is then it passes the control to bootloader here, right? So okay. So this is informational here. This part is informational. This part is informational. Okay, the first stage of bootloader passes control to second stage of bootloader. And the second stage is the where it goes into the grub2. Okay, I may have to update this here. This is a little bit old here. It goes into the boot partition, right? Yeah. And then the second stage of bootloader initializes the kernel. Okay, first stage of bootloader controls the passes control to the second stage of bootloader, which is in let me see here, cd grub2. You may not able to see the bootloader here because it's even before all these files are loading.
Yeah.
Okay, so now the second stage of bootloader second stage of bootloader, what does it do?
Device is that.
No, the first stage of bootloader passes second stage of bootloader is sits in here, okay, and then it's doing the bunch of things here. Second stage of bootloader resides in /boot folder. Okay, so what is the second stage of bootloader doing? It loads the kernel. So this part is informational. Okay, second stage of bootloader initializes the kernel. If you look in here, VM Linux kernel image VM Linux init RMS file. Okay, so second stage, what it does, it loads this file here. Okay, you see the VM Linux file, VM Linux 3.101. So it's either load this file or whichever one is updated here. Over here we just have only one file here. So second stage of bootloader
They have the
loads.
dates next to it, Mr. Zafar.
Huh?
They have the dates next to it.
Yeah, this system we didn't update it. So what it does is it loads VM. It's actually a virtual VMLINUS. VM Linux is actually the image, okay, kernel image, and then what is do is, and also extracts the code, extract the if you do cat init rms 3.0, see, it's in the binary. What? All this thing got messed up? Okay, good. Okay, here's the thing, guys, you don't have to worry about too much. All these things are interconnected, okay? So what it does is this file gets extracted and this file is executing this file, and this file is written. So if you do ls-la, vmlinux.image. Okay, this is the biggest file in all this system here. If you look at this file here, init rms file, no, not that one, this one. This is one of the biggest files. So what is this file is doing is it's loading it, and then it extracts it and it loads this file here. It's like actually an image file. What do I say? Image file is actually operating system, I think. Yeah. Okay, so let's keep this here. It extracts the content of is extract the content of the file initramfs image. Okay, and then this is a kernel, right? This file is still active. Both files are active now. This file is still in command, I think. Yeah. Okay, this file is still there. So what it does is it also loads the drivers. Drivers from initramfs image. And then this one, the second stage of bootloader, still loading the kernel, right? Kernel file. So what it does is the kernel file starts the system first process, which is systemd. Okay, now the systemd is in control now. So what is the systemd process? So systemd has several processes, right? First one is it reads the configuration file from /etc/systemd. Okay, don't be surprised. This is where exactly we've been here. So if you do ls-l or history, so we've been going into, oh no, over here. So if you go up here, what I've been explaining you, this is the file systemd. Is this a folder? It's reading all the configuration files here. Okay, so in there the most important files is going to read is systemd directory. Okay, and it reads the default run level file, which is, what is the default run level file? Is this one here. Okay, so whatever this file is set as, whatever this file is set as, can you give me the example? What could be this default.target file could be?
Again, Mr. Zafar?
Okay, I'm talking about So whatever default target file is set as.
Is it a run level?
Yeah, this is a run level file. So what can be this default target file could be?
One of the run levels?
Which one?
3,
Three.
And good
5.
example. 5 and okay, yeah. But what is the name? What is the name for 3?
Multi-user target.
Very good.
And graphical.
Very good. Right here. So example.
We need to know multi-user and graphical because of the command. That's what we're typing in the command.
Yeah. Now you see all this is happening here. These are the stages of the. These are all these interconnected files is happening. All these stages.
Yeah, because it's the process of booting up the
Yeah.
system. Okay.
Then after that also, let me clear this cd, then it goes into cd rc dot no okay, so it's not the file, it's this file. If you go into this file here, it executes this file here, right? This file is added for the compatibility process, blah 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 blah, touch var lock sys lock local. What is this file doing? So this file is actually locking the run level. Okay, so please note that if you must run chmod -+x to ensure that this script will be executed, bring to boot.
Mr. Zafar, what is chmod again?
Change the permissions.
Yeah. Okay.
Ooh, look at that. It says cannot access.
Does CMPT have the access to that or the permission to that?
I'm as a root.
Oh yeah.
I think that file loads and disappears. Yeah, this file, it loads and then see it's saying touch file varlog local. It loads and it disappears. Oh, you need to know about scripting. When we start scripting, you will know all this here. So I'm not gonna make you confused here. So all it does is it loads executes etc rc.local. Okay, that's it. That's all to do. I think we are beyond point here. So tomorrow we'll do system password. recovery. It reads yeah, I like this. I'm in class.
Can I finish the chili?
Yeah. So what happens here is so this will bring up to the load the kernel. It does this. And now you will be at a CLI. Okay, good. So this is a good picture. You should keep in mind this is what is happening here, okay? So let me reduce the size here. Okay, that's it for today. I'll show you tomorrow how to crack the system password. And this is when you go into for the test, you have to crack the system. They will give you the system, right? They're not going to tell you anything. They'll give you system, and then you need to know how to crack the system, or else you're going to fail the test. You will never be able to get inside the system.
Right, that's the first question, just to crack
Yeah.
the code to get into the test.
Well, yeah, as a system engineer, you should know how to crack the system. And this is
Right.
exactly what happens here. If you have physical access to the data center, that's it. You are a very dangerous person in there. You could crack everything in there. Oh, tomorrow is 1st. All right. November 1st. Okay. All right, guys. This is it for today. I'm going to stop. And then tomorrow we'll catch up, okay?